welcome everyone for this performance clinic about Kubernetes Observability for SREs with Dynatrace. So today you don't see Andreas Grabner hosting and presenting this webinar. Don't worry, he's safe. He doesn't have any problems. It's just that I decided to take the spotlights for 1 hour and enjoy it. At least I will try to enjoy it. And so my name is Henrik. I am the cloud native advocate. So I work mainly on everything related to observability and cloud native technology. And you can reach out to me on LinkedIn or Twitter. So if you see this Lego character, don't be afraid. This character really exists. It's my avatar. So it's not a fake account. It's a real account, in fact. Today, before we start, I would just to remind you few information. So first of all, for those who are not using Dynatrace on daily basis, don't worry. You can still try a trial, and everything that I just presented today, you can try it out from your own. So there is a link here to start a trial. Otherwise, there is plenty of amazing tutorials as well. So if you want to learn more on how to install the Kubernetes operator, all the stuff like this, you can go to the tutorials and figure out and learn more on how to deploy and how to utilize Dynatrace in general. Last, I will definitely take advantage of this hour to promote a new YouTube channel that has been started this summer in July. It's the Is It Observable? So I started this in July, and I try to basically provide content to educate in observability. So it could be with Kubernetes or Prometheus and in general. So it's not only related to Dynatrace. There is always Dynatrace somewhere, but it's more about helping you if you have to implement any observability in your environment using any open source framework of the market. So the link is here. Try to look at the content, give me some feedback. If you want me to change a few things, I will be more than happy to get your feedback to improve the quality of the content. And of course, if you like it, don't forget to like and subscribe to the channel. Otherwise, you may have heard about the Pure Performance podcast that is presented by Andy, so Andreas Grabner, and Brian Wilson. So if you have never listened to one of those podcasts, I will recommend to click on the link, consume some amazing. So they will have always great guests. So it makes completely sense to listen to the podcast. All right, so I think I did most of the housekeeping rules except one. It's a webinar. It's recorded. So if you have any urgent stuff to deal with, don't worry. You will be able to watch the content later on. And if you have any questions related to the content, like I said before, I will try to answer to the questions lively. But don't worry. At the end of the webinar, we will have a Q&A session. So drop your questions as much as possible so we can have fun during the Q&A. All right, so I think we could start now. So let's go. All right, so what are we going to learn out of this performance clinic? Well, a couple of things. So first, I know that everyone around here are pretty much experts in Kubernetes, but maybe there are a few people that are more beginners to the others that has less knowledge on it. So I think it makes sense that we remind a few concepts about Kubernetes. And also, I would like to remind a few problems related to Kubernetes. And those problems could basically be generate outage on environments. And this is something that we want to avoid as much as possible. So the other thing that we are going to figure out how to diagnose those problems using the Dynatrace. The Dynatrace Kubernetes operator. You see that we are basically going to natively collect all the various pillars of the observability space, and we will be able to detect problems. We will be able to create alerting or metrics based on logs. So we will see all this stuff, how you can achieve this. And at the end, what I like to do is we cover the easy peasy way of doing things. Now let's put our hands dirty and try to ingest external data, because at the end of the day, we're all using various observability framework. So it makes sense that we also collect them and push those metrics and events and logs to our Dynatrace tenant, so we could basically have a 360 view on what's going on our environment. All right, so let's start with the dark side of Kubernetes. So here in this screen, let's remind you the workload lifecycle. Why I want to do that? Because I want to remind that Kubernetes is an amazing orchestrating framework, and there is a lot of events that are generated in the background. So here in this slide, you can see in the top with the various icons, scheduler, etcd, config map, control manager, and API server. You can see those are the components of the master node. So if you're using a managed Kubernetes cluster in Google or in Amazon, you may not see this one, but keep in mind that this is the master that managed the orchestration of the containers. In the bottom, the two box, which is empty at the moment, those are the work node, and that will basically be the nodes that will basically be there to manage our deployments. So what happens when I deploy? So I have a deployment file, and if I click on deploy, basically I send it through kubectl. The first step, what happening is the first state, the work life cycle of the pod or any component in Kubernetes, the master node, he will try to figure out which node is able to take this new workload. So he will search the node, though it is available based on resources, in fact. So could be a CPU, could be memory. Once he has detected the right node, then the pod is in a creating state. A creating state means the app is not running yet. The app is going to run, but we need, because it's based on container, we need to pull out the image from a Docker registry. So if there's any problems to get at the image, we will be notified by events. And also if there's any volumes required, you will probably have errors saying that there is a volume missing, something like this. Once the image is pulled out, boom, we have our pod. And now we have a running state. So now we know everything. We know the various steps. And of course, sometimes Kubernetes could kill our pods for some reason. So let's figure out how that happened. So once upon a time, I had a cluster with two web applications, and we'll see we're going to use it on the demo side. We have the Hipster Shop from Google, well-known demo applications, and we have another application called the Sock Shop, well-known Dynatrace demo application as well. And let's say that we're using, and suddenly we have a pressure on a node. So the node starts to have resource issues in the memory side or in the CPU side, but in order to avoid having major outage or major problems on the infrastructure level, what Kubernetes will implement an event called eviction. So what happened is he will select one of the pod and he will evict the pod. Evict means he's going to kill the pod on this node and reschedule it on another node. So here we had two pods running on one node, and then after the evictions, problem resolved, we have one pod on one node and the other pod running on the other node. Wow, amazing. But keep in mind, there are a few constraints related to this eviction, because maybe my application is critical, and maybe for some reason, from the moment it kills the pod and try to reschedule it somewhere, there is a moment, maybe 1 minute, 2 minutes, where there is nothing is available for the users. So big outage for the customers. So that is something we clearly don't want to have in our production environment. The other story is that maybe all the nodes are in high pressure, so we are not able to reschedule anymore. So we are completely dark. And this is also a crazy situation. So how can we handle it? without any observability. I mean, we will use, of course, observability, but how can we manage it with just Kubernetes recommendations? All right. The first, you're probably all aware of this. We need to be gentle with our node. So we're going to control the workload by defining what we means request and limits on our pods. So you can define, when you define your deployment, you can put a limits and a requests in terms of CPU and memory. And depending on the value that you defined on the request and limit, Kubernetes will automatically apply what we call a quality of service. And there are three of them. So guaranteed. Guaranteed is when the request equal the limit, then it's guaranteed. The second one is burstable. So request is basically defined, is lower than the limit, so which means we are considered to be less critical app. And last is best effort, no limits defined, and so on. So why I'm telling you that? Because when there is an eviction, Kubernetes will basically kill pods based on the quality of service. So first, the best effort, and then burstable, and last, guaranteed. So if you defining those limits is a way somehow to protect your workload to being killed in case of this event. The other approach is defining quotas on namespace, or you can do also on the nodes, of course. But why in namespace? Because usually we separate our apps based on namespaces, which makes completely sense. So if I want to control that this app is less important than the other, then I will probably try to put limits on the namespace. So then I will make sure that the namespace will not overconsume and impact my other workloads. So that's the first solution, basically putting limits. All right. The second solution, which is pretty, I think, a bit more powerful, it's the pod priority class. So you will define a pod priority class, and you will define a value. And based on that value, you can see on the screen here, that will basically help Kubernetes to figure out that this workload or this pod is very small, less important than the other pod or the larger part. So you will basically define these concepts of small workload, medium workload, and last large workload, or even could be very creative. And so this is a way, of course, when there is an eviction or something happening, then of course this will be also considered by the master node when he has to evict pods in your cluster. The other thing is when you define request limits, we saw it before. If you reach out or you overconsume, you reach out the limits, then there is what we call out of memory or system. Basically, we have overconsumed. Kubernetes says, hey, you're not allowed to consume more, so we're going to kill you. So this is also an event that we were pretty much interesting as well. So have you seen? So we know those events, we know how to predict them, to prevent them with approaches. But again, I don't want to implement that in my production environment without knowing the impact. And the other way also is, if they, in case of an eviction, what is the consequence of my user? I want to make sure that I always provide a good quality of service to my user. So how can I do that? And there is an awesome practice in the SRE space. It's chaos engineering and load testing, of course, because, if you do chaos in your environment, then there is no traffic. Okay, so there is problems, but you're not able to measure really the impact of those experiments or disruptions that happen on your cluster without any real users or synthetic users in our case. So how can we simulate eviction? It's quite complicated, but sometimes you can succeed by doing this approach. Let's say we have 3 nodes, all right? And in those 3 nodes, what I like to do is basically to cut down one of the nodes. So I'm going to node drain. So node drain will be like a post. So no extra workload will be there, which means if I need to reschedule anything, they will be scheduled elsewhere. So basically, I'm simulating that I have less infrastructure than expected. Then I want to make sure that I'm putting pressure, because to get an eviction, I need to put pressure on the node. So I'm going to generate CPU stress on the nodes. I will simply generate memory stress on the nodes as well. I can also simulate like a pod memory usage, heavy usage. So then that will basically force Kubernetes to kill due to the out of memory events. So that's the concept. Once you have defined your experiments, fine. Then, of course, what we need is to generate some stress, or not stress, some traffic on our cluster. So in my case, we will see later, we have two apps. So I have a test that will stress one app and the other, because I'm interested to figure out, okay, which apps are more impacted due to those events during my test. So now we know how to do that. So now, in my case, small animation, we know that this node is stressed. So we may think that the workload will come back to the third node. So now, what are the observability pillars that we need to pay attention when we have to deal with those issues? Well, metrics, obviously. Metrics, because we need to figure out how much resources, or how is my service available. Anything related to health, availability will help me to figure out how good I am when I'm serving my users. The second source is logs. Logs is an amazing source of information. And Kubernetes events. You see, Kubernetes is throwing tons of events, so we definitely want to collect those and take advantage of those, because at the end of the day, if we have a system out of memory event happening, I want to be alerted, or if I have an eviction event, I want to be alerted to prevent or to do stuff and avoid a catastrophe on my production environment. So, and the last, of course, there's traces, but again, keep in mind that we are pretty much focused on how my cluster is behaving. I could also include traces, but here we're going to focus more on those three pillars. Even if at the end of the webinar, we will talk about traces later on. But in the case of this particular story that I'm telling you, those are the three main pillars that we should use. All right. And by the way, the Dynatrace Kubernetes operator, when you deploy it, will naturally cover those three pillars and more, with also the traces. So you just have to deploy the Kubernetes operator. It will instrument your pods. It will collect logs automatically. He will also report back Kubernetes events. You will also get metrics as well. So yeah, easy peasy. I don't have to connect, to ingest stuff. So that's, I would say, is the easy approach to handle that type of situations. What is the process to diagnose? Well, let's have a look at this. So the first is usually we start with the source of truth. So we want to check the cluster health. So for that, you could start from the service, because at the end we want to measure how the user experience that we provide to our users. So we could check from the response times level, but then we will quickly jump to the cluster, because we want to see, okay, how are my nodes? Okay, they're fine. Okay, I see that one node is drained. I have most of the CPU and the memory has been allocated, but I still have a small CPU and memory left in case I need to handle some more workload. I want to check out how is my workload spread out. I want to check my namespaces, how they are, if they are in the limits, and also in the cluster view that you can see here. We jump in later on the demo side. I have the events. So the events, you can see we classify them by type of event. So here we can see we have 31 unhealthy events, 58 system out of memory events. So there is tons of reported. So, and you can see how they are happening. And especially here in my case, in this screenshot, you can see that there was a period where some load, and that was where I was doing my experiments. So it's pretty useful, that view, and you're fishing for a couple events. That's what you're looking at when you look at the cluster. The other source of truth, I indirectly talked about it, is the pods and the namespace. So we can jump into the pod screen and or the namespace screens, and depending on the events, those will be reported to one of those screens. I have also have an access, for example, if I'm looking at the pods, a couple of logs related to the pod itself. And similar to what we've seen on the cluster here, I can see only the events related to my pod. So we mentioned creating, running, pending, and so on. And you can see here in this example, it's scheduled. So scheduled means maybe we have killed the pod and we want to schedule it, but we didn't find any nodes to really run our pod. So that could be also a very interesting indicator as well. The other thing which is interesting, especially we mentioned about it, we want to have put limits and quotas in our cluster, in our pods, in our namespaces, in various areas of our cluster. And in this view here, you can see that there is, on the right side, there is a section with no data. And this shows you, in fact, what are the memory limits that has been defined. What are the CPU limits that has been defined? And here you can see no data. It's a sign for us that, okay, no limits has been defined on namespace. All right, I know that now. And then I can check on the pod and say, oh, there's no limit defined in the pod either also. So that doesn't sound very well. So it means they're all in best effort, remember, so then they could be potentially killed. So how can we proactively handle errors? So what are error events related to the evictions and the others? Those are events, and the events technically from the way that Dynatrace is collecting them, they are in logs. In fact. So if you want to convert an event into a metric and then create alerting rules, create dashboards, create SLO, you could be, once you have a metric, you can do tons of things, and you know that because you've been watching a lot of performance clinic in the past, so you can do tons of things with metrics. But here, I'll start with the log screen. So I didn't take the full screen because it's too big, but I started with the log screen. I put a filter to say, hey, just want to look at my Kubernetes cluster, blah, blah, blah. I want to look at the event with that type of reason. So it could be OEM, for example, or it could be eviction, or it could be unscheduled, unhealthy. And once you have built, you have that logs, then you have the button create a metric. So the metric is being created. The second step in Dynatrace, we will see that when we jump to the hands-on, we give a name to that metrics, of course, makes sense. And you will see the query, the query that has been applied on the log streams that is being collected by Dynatrace. And what is really, really important, especially when the metric side, is to have dimensions. You know, dimensions will allow you to split by namespaces, by cluster, by pod. There is so many things that you can utilize in terms of dimensions. So make sure to add all the right dimensions because they are probably in the log stream. So it makes sense to also add them as dimensions. So once you have created the metric, you will have to let Dynatrace collect new logs coming in the systems, and that metrics will basically be available. So once the metric is available, then I can take either the metric screen, okay, nice, but it makes more sense to jump into the metric explorer, where I can either build a graph or build my own expression, a metric expression here. This is what you see in the screenshots. And once you have the metric expression, and you know that you can use the same expression to build custom anomaly detection rules, you can create SLOs, so you can do tons of things. So keep in mind, logs is a really interesting source for when you have to diagnose or manage those problems. So you should clearly convert those into metrics. So when it comes to diagnose, like I said, usually what I do, what I try to do, is to check, first of all, by check the response time. So I look at, so in my case, I have built a graph, but I can check on the services, but I have built a graph that's showing all my services response times. And I'm checking out at the moment where we had this test to see if there is any services that are more impacted than the other. So here in my case, you can see that it's the carts service, which is in purple, which has significantly exploded in terms of response times. So yeah, there is potential problems behind the scenes. So I jump into the service, and then in the service screen, you can see there is dimensions related to the Kubernetes cluster, the namespace, the workload. So you can click on it, and they will bring you back to the dedicated screens. So then we can look at the events that we had in this workload or in this namespace. And then from there, if there are critical events that you have seen, and that could basically be aligned with a pattern where you have seen the response time increased, then you can jump into the logs, convert the logs, the events that make sense for you into metrics, and then you can start adding that as an alerting. Then you can rerun the test. Basically, it's just a way of improving yourself, making sure that you have all the right alerting rules that to prevent that type of events in your production environment. All right, so demo time. So like I said, oh, by the way, so everything that I'm presenting today, I have built a Kubernetes, a GitHub repository. So if you want to, just try it out and utilize Litmus Cow. So I intentionally picked up Litmus because they are part of CNCF. They are using heavily Kubernetes for that, but you can also use Gremlin and other solution out there. Every solution are pretty good, pretty awesome. So in my case, I'm using Litmus Cows. So I have several namespaces. I have one namespace for the online boutique, the hipster shop. One namespace, which is the default with the Prometheus and other exporters, and we'll see that later on. I have the stock shop. And that's it. So everything is monitored, and which I didn't add here is that I have, of course, Istio that will help me to drive the traffic, but also collect some observability metrics because as a service mesh, you can have tons of metrics that are really interesting to understand what's going on in your cluster. All right, so let's jump into Dynatrace. So I'm not going to show you the test itself, but let's jump into Dynatrace. So where is here? All right, so here is my cluster. So I ran several tests the last few hours. So let me take the last 2 hours. Here it is. So I have built a dashboard, and you see that the metrics that you can see here are coming from several sources. So let's start with the core support of Dynatrace, and then we can jump into other solutions. So like I said here, I've built this graph here. I can even start with from the services screens, but let's say that we are more, you can see that we have the carts, which has 9 seconds response time, which is incredible, very high for an internal response times within the cluster. So I can see here my service. You can see that the response has been highly increased, and I'm going to jump into the cart service, the carts. So when I'm in the carts service that is currently automatically monitored by Dynatrace, I can basically see more properties related to this service, and I can see that yes, it's running on this online boutique cluster, and it's part of this namespace, and we have the workload. I can see that a few problems have been detected, but here I'm not interested to talk about Davis. We will have a dedicated performance clinic related to Davis in the Kubernetes world, but let's do the hard work to show you the process. So here I clicked on the workload. So here I'm basically in the workload screen of Kubernetes. I can see, of course, the various CPU usage. I can see the usage versus the limits to see if I am overusing or not. So I'm almost all used most of the CPU that I've allocated. So I can look at basically how am I behaving with this specific with the limits that we've defined. So there will be a way for you as well to figure out if your limits defined are relevant or not, and slightly tune them. The other thing is here you can see a few metrics related to the service itself, because we have a Dynatrace is servicing, but we have no events. All right, so that's not here. So maybe we should jump back, and I want to look at maybe the namespace. All right, so I'm going to expand. I'm going to click on the namespace here, and from the namespace, I will jump into the dedicated screen for the namespace, and here it is. And the first thing that I can see here in this screen is we have no limits and quotas on the namespace. Okay. That is interesting. So it means that this app, let's say if the sock shop production is less important than the hipster shop, for example, then I have nothing controlling that I'm not over consuming resources, and I could potentially kill one of my impact the hipster shop. So that is a sign, and that will help me to drive, say, okay, maybe we should put some quotas. All right. Then I can see that we have killing events. So let's have a look at this. So I can see that a couple of database pods has been killed. Wow, that seems very critical. And that could explain why we have this response time just exploding. And then we have a lot of failed scheduling. So basically here you can see that during this simulation, we were basically not able to reschedule our pods on the other nodes because there were no CPU left. So that is a sign where if I need to do any maintenance, I need to do node drain one of the nodes, then I'm not able to do it because potentially this will, basically I won't be able to reschedule the work on the other nodes. So that is dangerous. So now that we have, we see that, so let's jump into the logs. Oh, I can also show you, of course, the cluster view, so I can do it right away if you want. Let's jump into the cluster view. So here I can see I have two clusters. One, is it observable? So that would be a way to remind you that you should pay attention to is it observable? And the other one is the online boutique. So let's jump into the online boutique. So I have here, I can see my different clusters, and I can see globally all the events happening. So I have a lot of pods that were unhealthy. So I have few indicators about this one. But yeah, so we already seen most of the problems, so I'm not going to stay much longer on the screen, but this is the new cluster screen of Dynatrace. Now let's have a look at the logs. So we said that we are collecting the logs. So let's have a look at it. So this is the log screen, and so you can switch to advanced filter here, advanced query, but it's going to be the same thing. If I click here, it will basically build the query similar to with the advanced. So I'm just going to click here to filter. So let's look at first. I want to just filter to the online boutique cluster, right? So that's the first thing. I don't want to. I just want to focus on the events related to this our problem. And there are two events that are bringing my interest in my case. So let's say we have failed scheduling. So it could be interesting that if we have a failed scheduling, so we were no CPU left, impossible to basically to collect to schedule new pods on our cluster. So that could be a critical situation. So we could basically take this filter. So online boutique, failed scheduling, and we can say, all right, so let's create a metric. So now we jump into the metric screen. So I'm going to log and say Kubernetes. So I already have created some other naming. So I'm going to name it events because it's an events, and then say failed scheduling. All right. So now we have our metric name, which reminds here the query. So maybe it makes sense that I don't want to take this online boutique because at the end, I don't want to just limit to this cluster. So I'm going to remove it. So then it's going to be, so here it's measure the occurrences, but you can also measure the attributes, but I'm going to measure the occurrences. So how many times we receive that logs in our from our cluster. Then I will add dimensions, because here I have a metrics, but you have no dimensions. Then it will be just painful for me if I need to do graphs to split by pods, split by namespaces, filter by cluster. So I'm going to select the one that I'm interested in. So let's say DT. Let's say maybe where's DT cluster name? Up. All right. Then we're going to take the DT pod name potentially to see which one we had issued to schedule. Kubernetes workload. If you see it, just let me know. A workload name, but it will be the same thing. And what else? What else can we take? Oh, maybe we can take the reason. We can take the reason, and the reason is always there, always already there, so it doesn't make sense to add it. But let me check if there is another dimension that will make sense for our case. Let's say the node name. Okay, so we have our 3 dimensions. We have created the metric. Now the metric has been registered, created, but it won't be applied to the existing log stream. So it means that this metric called log Kubernetes events fail scheduling will start to be available from the moment we will have new metrics coming in Dynatrace. So once we have the metrics, so let's try another metric. So let's say system, this one. Okay, so we have this one. So now we have, I have created this one several days ago. So I can basically go to Metric Explorer. And then similar to other metrics, I just have to drop the metric name. Here it is. I have the one that I'm interested in. And I can basically run the query, but I didn't have any system, let's say on the last 72 hours. We can see that we have a couple of events coming in. So I have it now, and then I can try to splitter by nodes, by cluster. So then we can figure out which nodes have that issue. And I didn't add the pod name, so that's my mistake. I'm sorry, but we can also have seen the pod name as well. So once it's been created, I have the metric with the metric expression. And as you know, as I mentioned before, we will be able to create dashboards, alerting rules, and of course, service level objectives if you are planning to do very, very deep dive technical SLOs. Keep in mind the SLOs usually are more customer facing. All right, so that's the overall journey. Now we have more content to deliver. So let's jump it, because I'm pretty sure that you are willing to learn other interesting things now. So now we've seen the Dynatrace way of doing it. You see, we didn't have to configure anything. Oh, sorry, we didn't have to configure much. It was basically automatically ingested by Dynatrace, so that's the beauty. But again, I know we're all using Observability framework, so how can I take advantage of my existing stuff that I have? Yeah, well, let's see that one by one. So first, Prometheus Open Metric Ingest. And I have delivered a few months back a performance clinic dedicated to that theme. So I'm not going to go deep on this one, but I would like to present a few things. In my case, I have there's an open source project. I will show you the URL called Event Exporter. That is basically collecting events count on Kubernetes events and exposing it into Prometheus format. So which means if I just add the annotations, so to be able to take advantage of the Prometheus Open Ingest metrics, please watch the performance clinic. You will see you will have to add annotations to your deployments. There's similar to Prometheus. And once you have added it, Dynatrace will naturally reach out to the exporter directly, not Prometheus server, and send over the metrics to Dynatrace. So that's the first way of doing it. Now let's see the second way. Oh, not the second way. We'll talk about tracing, because we also want to maybe ingest tracing as well, because maybe from the tracing, if we are more on the app side, it will be interesting why I'm slowing down these card services that we mentioned. And to do that, I can have traces. But here, I wanted to stay in the event approach. And there is an open source project called KSpan. KSpan is being created by Weavework. And Basically, it generates an OpenTelemetry trace of your deployment. So all the events will be attached to deployment. So it could be interesting to figure out why my deployment takes so much time. Is there a reason? So then you can see here we have all the OM kill and so on that happens, and we can understand what's going on. So so we have a solution, Kspan, that generates OpenTelemetry traces. And also, like I mentioned before, I'm using Istio. And Istio, if you are not aware, Istio, you can enable on Istio-D saying, I want to enable tracing, and I want this over to an endpoint. And then you will have some details on the dependencies. I mean, we already have it in Dynatrace, I know, but if you want to have fun and ingest this, you can have it as well. So to do that with OpenTelemetry, there is a component called the OpenTelemetry collector. The purpose of the collector is to basically, you can create a flow of collectors that will receive different sources, transform them, send over to another collector that will also do some stuff, and then send over to your backend that will store the traces. In our case, it's Dynatrace. So here, Kspan is generating OpenTelemetry traces in gRPC. And Istio is generating Zipkin, and Dynatrace is able to ingest metric in the OpenTelemetry HTTP protocol, which is the protobuf. So that's why I need to go through this collector, and I will create what we called a pipeline in the OpenTelemetry space. So the pipeline will have 3 steps. I will receive, I will process, in my case, there is no processing, and I will export. And exporting, in my case, simple. I just want to send it over to the OpenTelemetry Tracing Ingest API. Simple like this. The second one is, I don't know if you know, but OpenTelemetry covers traces, logs, traces, metrics, and logs. Logs is still experimental. It's not there yet so much, but you can also ingest metrics. So I would definitely recommend to not use this one for with Dynatrace. The other way with the annotations is the most recommended way. But let's say you have some metrics, but you want to add more details, more labels to your metrics for some reasons, because you will add extra dimensions to your metrics. And then once they've been ingested in Dynatrace, then you have more filters. And that's sometimes is what we're looking for. So here I have a receiver. So the receiver is Prometheus. Is going to scrap the data from my Prometheus exporter, the kubestick metrics. I will have a processor, and I will use one of the plugins called the metric transform. Metric transform, in my case, I want to add labels. I want to rename labels. You can do tons of things with it. And then I want batch. Why batch? Because remember, we're going to send over to an API, and we want to create a bulk of metrics. So to avoid creating a payload that are several megabytes, we want to basically create let's say 100 metrics we send over, 100 metrics we send over. So batch is something that you should use if you want to ingest metrics using the OpenTelemetry collector. And from the exporter, there is already a plugin available in the OpenTelemetry contrib called Dynatrace that is aimed for sending the metrics to Dynatrace ingest API. So it's very easy to configure. I will briefly show you this in a few seconds. Last is log ingests. Log ingests, so Dynatrace ingest log, we saw that, but there is a lot of agents called log collector and forwarders. Those components are aimed to basically collect logs. So small animation. So it will collect logs from various sources. It will transform it here in JSON because we easier to do some queries. And then we can also relabel. Basically on the logs, I want to add some context, which pod, which namespace, which nodes, which cluster, whatever we need to make our diagnose easier. Once it's been relabeled, then we could forward, and forward is, in our case, sending it to Dynatrace. So if you use Fluentbit, which is the most solution recommended for Kubernetes, there's 2 ways of sending it to Dynatrace. There is an official plugin in the Fluentd. So Fluentd is the big brother of Fluentbit. So you can still have an exporter that will send over to Fluentd, and Fluentd, with the help of the plugin, will be able to send it over to Dynatrace. Or if you want, you can also utilize the HTTP plugin. but there is more settings to do that if you want to be able to ingest properly those log stream in Dynatrace. All right, so let's do a short demo. I'm looking at the time. We still have a couple of minutes, and I want to do some Q&A. So let me show you first up my IDE. So this is the project that I'm using in GitHub. So all the stuff that you see here is available on GitHub. So you will be able to get advantage of all the chaos experiments that I've built, the load test, the SockShop deployment, and so on. So first thing that I do, so I want to first show you the deployment of the Hipster shop. So the manifest file here, which is the Hipster shop. So the first thing I do is, because I'm using Istio, and by using Istio, what is going to happen is Istio is going to inject in top of all my pods a sidecar proxy. So it's going to be an extra container sitting on top of our services, and Istio will be there to basically handle the communication. So your apps will never communicate directly to your target application. It will go through the proxy, and the proxy will reach out to the other proxy, and the proxy will reach out to your service. So it's basically a local host communication between your service and the proxy. And Envoy and Istio is exposing tons of metrics, which are really amazing. So what I'm doing here is I'm adding here the Dynatrace annotations. So the Dynatrace annotations, why? Because I want to let Dynatrace active gates that sits in the Kubernetes monitoring component to scrap the Prometheus metrics. So I just need the right port for where the Envoy proxy is exposing their metrics, and I need to have the right path. And this is available in the documentation of Istio. So if you add that to all of your pods, then from the moment Istio will inject the sidecar proxy, boom, we have our metrics. Wow, it's amazing. So I will show you in a few seconds what you can do in Dynatrace. So that's for the Prometheus injection. So adding annotations is the most recommended approach. Then I mentioned two things. I'm not going to cover the logs because I know that we will need it more than just 1 hour to cover everything. But I have these OpenTelemetry deployments. I've already prepared it, and I should have separated in two OpenTelemetry collector because to avoid consuming CPUs and memory. But here in my case, what I do is I'm using first a receiver Prometheus. So here I'm precising the targets where I'd like to scrap the metrics in my cluster. So Prometheus, kubestate metrics, node exporter, and also I've deployed another pod, which I mentioned, the event exporter. So those are here, and that will allow me to scrap that. So I just defined one of the receiver. That's it. Then I have another receiver, Zipkin, because I have deployed kspan also. So that will receive Zipkin is for Istio. So here I will receive all, I'm defining that I'm listening on this port. And then I have another receiver to receive the traces generated by kspan. Then on the processor side, the only thing that I've built is only for Prometheus. As you can see here, I am basically doing the bulk of metrics. And then here I am transforming. So for every metrics that I'm receiving, I want to update. And here I am updating some labels. I'm renaming them. So I want namespace to be renamed into Kubernetes namespace name. I want to add a label with the Dynatrace Kubernetes config ID. Why? Because I want to register my metrics to the right dimensions of Dynatrace. And here I am also adding some information to the pod ID, because that also will help Dynatrace to index the data. And last, if you have the node ID, so then that will basically help you to filter later on your metrics on your graphs. And last is the exporter. So I just need define the various API endpoints of Dynatrace, and that's it. And then you define your pipeline. So I have a pipeline for the traces, which received Zipkin and OpenTelemetry and resend it back to Dynatrace. The other one is for metrics. I receive Prometheus, I transform, I batch, and then I send it to Dynatrace. So it's very simple. Again, it's an example. So you can take advantage of this, play around, and then. So let's jump into Dynatrace and see what we have here. So the first thing, let's go to the dashboard. So here, the first thing that I have, if it takes a few seconds, all right. The first thing that I built here is I have built this Kubernetes events. This is coming from Kubernetes, the event exporter. So it's basically a querying counting the number of events that are received, split it by type and by namespaces. So it's very easy to do that. The CPU capacity and so on, I am using the node exporter. So it's Prometheus metrics as well. For the all healthy pod ratio, this is coming from the logs, so that is pure Dynatrace. And this one here, pod availability, it's coming from Istio. So I am basically, if I edit the style, you will see that the query is simple. I am counting the request total, where the response time is 200, and I divide it by the total number of requests. So, and then I'm splitting by apps and so on, and I'm trying to figure out how my apps are available during that time frame. So for some reason, I have only one app, so that's interesting. But I should have more apps with that query for sure. So that's what you can get on the traces, because I'm looking at the time. We have 8 minutes left, and I want to do some Q&A. So last thing I'm going to show you before we jump to the Q&A is the distributed traces screen. So if I go to distributed traces and I go to ingest traces, which is here. So this is all the OpenTelemetry traces. I have several traces. So I have the Istio one, but here I have I have the case span. So like I said, this is a trace showing you the node updates, the entire flow of events for a certain deployment. You can see that the timing of the event is really high because it attached everything to a deployment. Again, keep in mind that this project case span is experimental, so it's nice, but again, it's difficult to utilize the data coming out of this one. So if you want to play around with OpenTelemetry, that could be a way of doing it as a pure game. Also, the other one I mentioned, the event exporter that I was using, is this project. So this will basically count the number of events, and you can do a lot of queries once you have ingested it. So it's pretty awesome. And last, here is the GitHub repo that I was mentioning, related to this performance clinic. So if you want to deploy, play around with Litmus Chaos, do some load testing, see how to utilize this OpenTelemetry pipeline that I have built, you can go through this tutorial step by step, and you will be able to replay it on your own cluster. All right, so let's jump back to the slides. As a takeaway, I would have a few takeaways on few topics. So first, Kubernetes. Don't forget to define quality of services. So request and limits, it will be always helpful. Second one, resource quotas on your on your namespace and your nodes, pod priority classes, of course, as well. On the observability side, make sure that you collect metrics, traces, logs. I mean, you know that. That's natural for you. But keep in mind that logs is a really interesting source. So please take advantage of that. Define metrics based on your logs. And then you can define alerting rules, custom anomaly detection rules. You can define SLOs, but this will be more on the SRE side. And last, don't improvise in production. Chaos engineering is obviously going to be very helpful to make sure that the right rules are in place, the right alerting is there, the right dashboards are there. So then you are confident when those events happen in your production. And defining SLI, SLO will be obviously helpful because you will always keep track on customer certifications and response times, availability, and others. All right. Before Q&A, I would like to share a few resources. So if you want if you don't have any Dynatrace cluster, yeah, start a trial. There are a few performance clinics that I will recommend to watch. So the one on the Kubernetes platform in general, one is on the monitoring as code, Monaco, because if you want to automate, I didn't cover that piece, but Monaco is an amazing open source solution that is available. Kubernetes at scale with Prometheus, I was referring to this one. If you want to just see how you can ingest Prometheus metrics, there will be this performance clinic is dedicated to that theme. And last was the last performance clinic that I was presenting with, I mean, not presenting, but this I was hosting. So it was Daniela Rabisser and Wayne Seeger that was doing an episode on Dynatrace and OpenTelemetry work better together. So a lot of different content you can see on our university. You to a look at the Pure Performance podcast or listen to it more and have a look at, is it observable? All right, let's jump into the Q&A. I'm watching, and we still have 3 minutes. Wow, it's amazing. We did a lot of things. So there is one question which is really specific. So they are announced Kubernetes SLIs so it's on Kubernetes, or how I can configure them in Dynatrace. It's a great questions. Thanks for bringing that up. So I'm going to note that down and I will look at it. And that could be a topic to cover because it makes completely sense. I really like that approach. So I cannot answer your questions. To be honest, I have not invested so much on this particular area that has been provided. So thanks, Pavel, for bringing that up for sure. Question, please let us know if there are any best practice on auto tagging in Kubernetes monitoring by Dynatrace. So the auto tagging, you can do it. There is a lot of rules when you apply tags. You need to make sure, first of all, that everything has been pretty well indexed, sort of the cluster, the node, the config ID, all the stuff. And once you have it, then you can put rules related to your tagging rules based on this. You can also create a management zone as well. So it's something that is going to be improved in the future. It's still possible, but it will be much more easier in the next coming month for sure. One thing I would like to have is to alert based on Kubernetes events. For example, when one or more nodes are not ready, any ideas? I currently use the static thresholds based on a total count of nodes. So that's the way I would recommend is to do credit metrics based on logs. So then you can count the number of events that has been thrown in the logs, and you can create alerting from there. If you want, you can also use the event exporter that I showed you. That will do the same thing, but logs could be a good source for your need. What's the minimal version of the Dynatrace management cluster or ActiveGate to view the namespace quota limits in Kubernetes? I think, to be honest, it should be. Let me check on mine. It should be. It's since the release of this summer, so. I think you should have it if it's a managed. There is 2 weeks differences. So, but I will get back to you on the exact release number. I don't have it in mind, to be honest. I don't want to say something that doesn't make sense. So I will get back to you on this one. But it's been released this summer. So you probably have it in the next few weeks. You will have it in your managed cluster. What type of network port should be opened for communication between Kubernetes and Dynatrace cluster nodes? It's a great question because you could basically it's the Dynatrace operator interacts with the API, and then in fact when we install the Dynatrace Kubernetes operator, it has its own ActiveGate, and that ActiveGate will communicate with our Dynatrace cluster. The port is a good question, but it should be the similar one that you have used with a normal ActiveGate, I would say. Will you send us the webinar presentation and record? Yes, this webinar is recorded, so you will probably you will receive the links, and it will be available soon in the couple of in few hours or day or one day, maybe tomorrow. So it's a good question. So what is the difference between the standard metrics supported by Dynatrace and the one coming from the outside world? I would say that from the moment it's the Dynatrace speaking of the metrics, it's attached to a context. It's much easier when you filter. You can all the standard features that we have in Dynatrace are just working perfectly. So it makes your life easier, to be honest. But there's always stuff that you want to collect outside of Dynatrace, of the traditional Dynatrace support. For example, I want to report back my CI metrics, how Jenkins is behaving, how much the duration of our pipelines. It could be also backup systems. So Velero is one of them on Kubernetes. So you can also collect metrics on those through through Prometheus exporters. So they are, if you want to extend the observability, there's always a site application that exposes metrics. So it could make sense to also send it over to Dynatrace. It's just to extend your understanding on your environments, I would say. Same thing for OpenTelemetry. If you decided that I don't want to use an agent because it's somewhere up in other applications, or for example, in my case, Istio is generating traces, and it would be interesting to get it. So you can try to do that. So it's more about what is currently missing and what would help me to get a better view, a better understanding on my environment. Then I will start to ingest external metrics for sure. So it's always about increasing the observability. Does Dynatrace out of the box gives HTTP request and response metadata? Yeah, yes, of course, for the pods. Yeah. It's out of the box. So I decided to use Istio because we had several customers that use Istio and other service mesh, and from Istio you have tons of metrics. So it could be also a really interesting source of data. So I just decided to use it as an example. Again, we already have the data. Same thing for the node health. We already have it from Dynatrace perspective, but also ingested with Prometheus, just for the example, but most of them are there. All right, so I think most of the question has been answered. So I see that we are over the hours. I hope that you enjoyed this hour with me. Let's, I have all the questions in the chat. I just saw that. So I will try to extract them later on, but it's already the time. So I will thank you everyone for spending 1 hour with me. It was just amazing. I mean, at least I enjoyed it. I hope you enjoyed it as well. Take advantage of the content I've built on GitHub. Let me know if you're able to do stuff, and reach out to me if you have any issues. All right. So have a great end of the day, and see you soon for another performance clinic. Bye.